All right, a gas contained in a rigid container has a pressure, so we're given pressure, and we're given temperature of that gas, and is asking you what is the new temperature and at a change in pressure. So pressure and temperature are changing. Let's start with the ideal gas law. PV equals nRT. Let's move all the constants to one side and the variables to the other. So right now the pressure and temperature are the only things changing. So we'll bring the temperature over there, and then the volume is constant. So it's a rigid container. Volume is not changing. So I'll move the volume over to the right side with the other constants. So P over T, just dividing through by T and dividing through by V, is equal to NR over V. So this side is all constant, so it's not changing. So whatever we do, the pressure and temperature is going to remain equal to that constant. So we can say P1 over T1 is equal to P2 over T2. And it's asking us to solve for the final temperature. So let's rearrange this to solve for T2. We can do that by cross multiplying. That diagonal will be one side of the new equation, and that diagonal will be the other side of the new equation. All right, so we're going to get T2 is equal to T1 times P2 over P1. You got to take care of this temperature, make that into convert that into a Kelvin. 38.9. Let's add 273.15 to it to turn Celsius into Kelvin, and we're going to get 312.05 Kelvin. We need one more conversion because we have two different units of pressure. So let's convert this to, it doesn't really matter, let's convert to atmospheres. So let's convert millimeters of mercury to atmospheres. So 456 millimeters of mercury. Convert that to atmospheres. So we need millimeters of mercury on the bottom of our conversion factor, and the desired unit on the other side of that. All right, so the equality is 1 atmosphere is equal to 760 millimeters of mercury. Plug those numbers in. 456 divided by 760 is 0.6 atmospheres. 0.6 atm is the pressure of P1. Let's label that. This is T1. All right, now we can finally plug these numbers in. T1 is 300 and, let me line these up a little better, 312.05 Kelvin. Our final pressure is 1.23 atmospheres. And our initial pressure is 0.6 atmospheres. All right, atmospheres cancel out. We'll be left with temperature. How many sig figs we need? 3 sig figs. We can just do 640. I'll put a dot there to signify that they're all significant. Kelvin.